Central retina is actually occupying the most posterior parts of the primary auditory cortex. Primary visual cortex.
5 minutes later.
Okay guys, now let's see the primary visual cortex. Like lateral genital body, the primary visual cortex also has 6 layers. The fourth layer is actually divided into A, B, C alpha, C beta. Okay. So as I mentioned before, the magnocellular pathway, they are actually going to the C alpha. They're going to the C alpha. They're going to the C alpha. Okay. Whereas the 4A, okay, the 4A and the C beta are occupied by the parvocellular pathway. Parvocellular pathway. As I mentioned before, intralaminar portion, right? From this area, from this, the impulses from this area are actually going to the area number, layer number 2 and 1. Area number 1 and 2. They are very much concerned with the color vision. Like our P ganglion parvocellular pathway, they are also concerned with color vision. Okay. Let's add some details to this primary visual cortex, right, guys? See, actually in a primary visual cortex, we got 2 columns. One is ocular dominance column, and second one is the orientation columns. See, the orientation columns, guys. If you are looking at the primary visual cortex, okay, it has numerous numbers of orientation columns. See, there's a vertical columns present inside the primary visual cortex. Inside this there are numerous numbers. Numbers of orientation column, guys. Inside each orientation columns, there's for 6 layers, as I mentioned, right? 1, okay, 5 and 6 layers. Okay, while we are coming across this primary visual cortex, okay, we can see that there is a difference of 5 to 10 degree changes in each orientation columns. There will be difference of 5 to 10 degrees. So that from 0 degree to 360 degree, for each specific degree, there will be a specific orientation columns present in our primary visual cortex, guys. I will tell what is the significance of this. Okay. So let's see our subject. As a subject, see, first of all, while we are seeing an image, in this case, we are seeing this boy, right? While we are seeing this image, our primary visual cortex first identifies the lines, our borders. So these lines and these borders, guys, these borders and these lines and these borders are first captured by our primary visual cortex. Which one does this work? And the name of the cells is called simple cells. The simple cells is the one which are actually present inside the orientation columns. See, inside these orientation columns, there are layer 1, 2, 3, 4, 5 and 6. Inside the layer 4, the simple cells are actually present, guys. Okay, simple cells are actually present. So while we are looking at object, for this case, this guy, first the borders are organized by the simple cells present inside the layer 4, guys. Okay, let us take this boy is actually oriented in 10 degrees. Okay, let us take this boy is actually in 10 degrees. Okay, for this particular 10 degree, there are the particular orientation columns, as I mentioned before, right? There are numerous orientation columns which are specific for each degrees, right? So for this instance, we take about 10 degree. For this particular 10 degree, there's a particular orientation column is present in our primary visual cortex. Okay, so let us suppose to take this is the orientation column for that particular degree, for the particular 10 degree. So the lines and borders of this 10 degree guy, 10 degree boy, is first of all recognized by the simple cells. Then, as you see, with the same 10 degree, the boy is actually moving. The boy is actually moving. So this moving, right? This moving is actually recognized by the complex cells. Moving is recognized by the complex cells. They are present in another layers, not in fourth layer. They are present in other layers. Okay, so the moving is actually recognized by the complex cells. Moving, but you have to remember with a same orientation. For instance, we are take about 10 degree. Okay, then this boy got some length, right? Specific length, right? For suppose let's take 10 meters. Okay, for a 10 degree, a particular orientation column is actually activated. In that particular orientation column, the fourth layer, which has the simple cells, actually recognize the borders. Then the boy is actually moving laterally. It is recognized by the complex cells. Then he got some length. The specific length is recognized by another cells called hypercomplex cells.
Do it!
Recognize the length, but you have to remember the same orientation, just nothing but 10 degree. Okay, now, so the primary visual cortex got some gross idea about the visual scene we see, right? Because you see, we now just got some gross idea, right? The borders, and he is moving right or left, and the specific length, like that. We didn't much concern about the colors. Where? See here, the visual details are actually recognized by the temporal cortex and the secondary visual cortex. These areas are primarily concerned with the textures, the colors, the details, guys, so that we can get the particular color for this particular scene, right? So that's all, guys. Hope you all like this. Thank you for your support, guys.